Let's start with standard 8.NS.A.1 about number sense. You should know that numbers that aren't rational are irrational, and show that the decimal expansion for a rational number either terminates or repeats. Let's start by looking at rational numbers. Rational numbers can be expressed as a over b, where a and b are both integers, and they have decimal expansions that either terminate or repeat. Let's look at some examples. 2/3 is a rational number. It can be expressed in the form a over b. Notice, if you were to divide 2 by 3, you would wind up with 0.666, and the 6 would keep repeating. Notice, this decimal expansion here repeats. This is a rational number. 2/3 is a rational number. How about 3/4? Well, if I divide 3 by 4, what I'm going to get is 0.75. So not only is it expressed in the form a over b, but the decimal expansion terminates. That means it ends. There's nothing past this 5. How about -6? It can be expressed in the form a over b, -6 over 1. Both -6 and 1 are integers. That's a rational number. And then the square root of 4. The square root of 4 is actually equal to 2. 2 can be expressed in the form 2 divided by 1, 2 over 1, a over b. In fact, any perfect square, when you take the square root of it, that will be a rational number. Now let's look at irrational numbers. Irrational numbers are numbers that cannot be expressed in the form a over b. Their decimal expansions do not terminate or repeat. Some examples of irrational numbers would be things like this: 7.325973684015 ... goes on and on and on. It does not repeat or end. This is an irrational number. Pi also does not repeat or end. You probably remember pi days at elementary where you had pi written out in very long manners with it never repeating. Pi is an irrational number because it never repeats or ends. How about the square root of 2? If you put that in your calculator, you're going to get 1.4142144562, and it goes on and on and on. It does not repeat. In fact, the square roots of all non-perfect squares are irrational numbers. That would be the square root of 2, the square root of 3, the square root of 5, square root of 6. It goes on and on. Now, let's look at the other part of this standard. Convert a decimal expansion that repeats eventually into a rational number in the form a over b, where a and b are both integers. We're going to look at 2 examples. The first example is this. We're going to convert 0.3 repeating, this bar over it means it repeats, into a fraction in the form a over b. We start out by setting x equal to our repeating unit. So x is equal to 0.3 repeating, because we want to get rid of this repeating unit. To do that, there's 1 decimal place back here. So I'm going to multiply both sides here by 10. If I multiply this x by 10, I have 10x. If I multiply this repeating 3 by 10, I get 3.3 repeating. Notice, I now have the repeating unit behind the decimal. What if I subtract everything here? See, these are equal, so I can subtract them. What if I subtract those from what I've just written? My 10x minus x would give me 9x. My 3.3 repeating minus this 0.3 repeating gives me just 3. Now I have numbers, integers that I can work with. What if I divide my 9x by 9 and the 3 by 9? Now I've got x is equal to, well, I would wind up with x is equal to 3/9. But I can reduce 3/9, and if I reduce 3/9, x is equal to 1/3. I now have a rational number. I've got this in the form of a over b, where 1 and 3 are both integers. And let's try one more example. What if we've got 2 places behind the decimal that's repeating? In this case, I've got 4.81, and the 81's repeating, and they want us to convert it into a fraction in the form a over b. I'm just going to hold this 4 over on the side, and I'm going to work with this 0.81 and convert it into a fraction. If I've got x is equal to 0.81 repeating, that's where I'm starting. Remember, I take the repeating unit and I set it equal to x so I can get rid of it. I want to move this 2 decimal places. So I multiply both things by 100. If I multiply x by 100, I have 100x. If I multiply this repeating unit of 0.81 by 100, I have 81.81 repeating. Now let's subtract this right here from both sides. I'm going to subtract x from here. I'm going to subtract the 81 repeating here. Since these are equal to each other, I can subtract them on both sides. 100x minus 1x gives me 99x. 81 plus 81 repeating minus the 81 repeating, decimal 81 repeating, gives me just 81. If I divide both sides by 99 to get the x by itself, I wind up with x is equal to 81 divided by 99, or 81/99. If I reduce this, if I take 9 out of both of these, I wind up with x is equal to 9/11. Now let's don't forget, up here at the top, we started with 4.81. So we're going to have to put that in. 4.81 repeating is going to be equal to 4 and 9/11. That covers our rational, irrational numbers, and it covers converting a repeating decimal into a fraction.